All right, so we spent the first, this is for the video more than it is for you guys. We spent the first 10 minutes, 15 minutes or so graphing through these problems and realizing when it's growth, it's increasing from left to right. When it's decay, it's decreasing from left to right. And that the range and the domain should be the same for both. The domain for all of these problems is all real numbers because it keeps going left and it keeps going right. The range does not go below the y-axis no matter what I plug in. We'll get to negative exponents later because that doesn't make it of negative value, okay? So we've got the A shows us, and you can see this in every one of these problems, I hope, the A is the y-intercept, okay? The A is just the y-intercept, where it crosses the y-axis, okay? If you don't have this, write it in now, okay? Now, down below, your graph should look like this, and we're going to fill in this information together as well. So again, we talked about B, if it's less than or greater than, determines whether it's decay or growth, right? So if it's greater, it increases, we can see it increasing. And if it's less than, it decreases, we can see it decreasing. I went and found a couple of points for each one of these when I did it, because there's sketches, I guess we really didn't have to, but I wanted you to do it anyway. And notice again, the domain is the same for all of them, the range is the same for all of them. So, what does it mean when B is greater than 1? Well, the graph increases from left to right. I wrote it like this, but it means it's from left to right. That causes it to have growth, right? The graph from 0 to 1 decreases from left to right. That causes it to be decay. Now I'll give you a second. I see some people kind of rounding that up before we talk about what's at the bottom. What do we notice about the domain, the range, and the horizontal asymptotes, which we haven't really talked about yet, okay? What is the domain? What do we notice about the domain? I've actually said this answer a few times now. It's all real numbers. That's been for all of these, right? So on the next page, we're going to shift it around a little bit, and we'll see how that changes. But for all of these, the domain equals all real numbers. Okay. Now we've got the range. The range is y is greater than 0 for all of these problems. It's the same. Now for this horizontal asymptote thing, horizontal asymptote. Anybody remember what an asymptote is? We talked about it in the graphs of tangent. We talked about vertical asymptotes, where they just kind of look like the dashed vertical lines. Remember that? Okay. Horizontal is just a dashed horizontal line. Okay. And a horizontal asymptote means the graph cannot cross that line. What is the equation of the line it cannot cross? Very close. Y equals 0. Okay? It goes through the y-axis, so it's y equals. So the horizontal asymptote here is y equals 0. And what that means is, I'm going to go back in a red pen, you don't have to do this. What that means is the graph never crosses this, the line y equals 0 on any of these graphs. Okay, and I can go up and do it above too, but I don't need to. Okay. That's that. Kind of coming back to what we were talking about Friday, a lot of this was kind of tying up more of the odds and ends of them, but they all kind of look the same depending on if they're exponential growth or decay. Some of them increase a lot faster. If you look at number 4 went up crazy fast, versus number 2 went up a lot more gradual. Well, it's because it has a higher factor, this 4, and that 2 make it go up faster. Getting an A has something to do with it too. All right, let's go to the next page. All right. Oh, that's not the next page. Yeah, it is. That's your next page, right? All right, so now we're going to take a look at how this works when we shift it all over the place, okay? And these are the types of questions that you would see like on an ACT or SAT. And this is all we're going to do today, is just some graph recognition. It's not really doing any math today, okay? So for the next one, number 6, the graph of a log function. Logs, if you look on your calculator, you see the log button. I've noticed that. Ever since I was a kid, you can just see the log button, right? Okay, we're not even going to push it today. I'm just having you understand that logs are the opposite operation of exponentials. In other words, if I asked you to solve, very simply, if I asked you to solve 3x equals 6, what would you do to solve that? Divide, why?
To
To get rid of it because it's the opposite operation, right? This means times, so the opposite is divide, right? If I have x plus 3 equals 6, what would you do to solve that? Subtract 3 because it's the opposite. That's called the inverse operation. Inverse operation, to do the opposite operation, same thing, okay? So, logarithms are the opposites of these exponentials, and you can see it. The graph of an exponential, remember, would go like this. So, its logarithm, its other one, would go the exact opposite way. There's actually a formula to it, we're not going to get to now, but they reflect each other across the diagonal. So in other words, the diagonal, which would be like this, it would reflect. So instead of a graph going like this, it would reflect to go like this. Kind of makes sense? Okay? Again, not trying to learn about logarithms today. That will come the rest of this chapter. All I'm trying to do is say, look at that graph and tell me what the domain and range are. You got A, B, C, D. Which one is it? Look at the graph. What does it look like the domain is?
C.
Looks like it's C. So all of the, oh, you know what? I'm glad you said that. You just answered what range is. Because range is my y values, right? Domain is my x values. So C is the only one it can't be because, well actually, it can't be D either, right? Because D says y. It's got to be either A or B. And what do we know about these asymptotes? What do we know about that line y equals 0? What did I say? Can it go past that line? No. Can it equal to that line?
Yeah.
No, it's going to get close, 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 but it's never going to quite touch it. So which one's the answer? B, because it's not going to actually equal it. It's going to approach it and not quite get to it, okay? Now, this right here is my range. But another way to say that, how would I say that? We've been saying it all along. From negative infinity to infinity.
All real numbers.
All real numbers. Okay. If you wanted to write from negative infinity to infinity, you can write that as well. But we know the symbol is real simple. Good enough. Okay? Alright, let's look at number 7. Now, what it's saying here in number 7 is determine what is not true about this graph. And this is an exponential, what is this? Decay or growth? Decay, because it's going down, it's decreasing, right? Okay? So, which statement is not true? Is the domain all real numbers? Think back to all of these exponential functions. Did we say domain is all real numbers?
Yeah.
Yes, okay, so that's true. Let's make sure, put a slash through that because that's definitely true. Okay. How about the next one? As, this is a little bit interesting. Wait. It said that's not true, right? Yeah, I don't know what. Yeah, I'm doing right. I think I did it the opposite way. How about as x approaches infinity, f of x approaches negative 1. Now this is a little confusing, okay? But do you see how this actually went through the x-axis on this graph, right? So is that true?
Yeah.
Yeah, as x approaches infinity, which means as x goes that way, this function approaches negative 1 but never crosses it, right? That's kind of how we write the domain and range as we're going to go into a different chapter. Okay? So this is correct as well, right?
C is obvious.
C is obvious. Why? Because the y-intercept is 3. Yes, you're right. It crosses the y-axis at 3. So that's true. So it better be just D, right? Is D true? Maybe none of them are true. As x approaches negative infinity, f of x approaches negative infinity. So look at the graph. As my graph continues to go that way, is it going up or down? It continues to go that way, and it's going to keep going up, 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 up. It's not going to like go down like this, right? It's going to keep going up. This is saying that as it approaches that way, this is going down. That's obviously false. Okay. So let's circle D. D is the only one that's not true. What's my range here? Well, I'm going to kind of piggyback off of what Tori's been saying and write y. And do we know if it's going to be greater than or equal to or less than? What do you think? Is it going to be equal to? No, never. It's never going to approach that line. Where are all my y values? Are all my y values above that line or below that line? Above. So greater than what? Negative 1. right? It kind of came from that right there. F of x approaches -1. Where's the line where I cannot go past it? And this is called a shifted exponential graph. Everything we've done so far has been you can't go past 0. This one can't go past -1 because that's what the graph says. Okay? Now I'm going to ask you to shift it. I'm just telling you that sometimes if we move them over, that's what happens. All right, let's look down at the bottom here. So I've got which of these graphs, A, B, C, or D, represents that function? Grab your calculator. Go to y equals, and type in, oh, how do I find that? I gotta know how to find it. Can I see it from here? Just a second, that's what I'm trying to remember, is how do you get the 2 down there? You know what, we're not gonna do that, okay, we're gonna do it on Desmos. We already got Desmos open anyway. It's gonna be easier on Desmos, okay? So, if you go to clear out your equations, press y equals, and then you see at the bottom there, they got the keyboard looking thing, go to functions, where it says functions to the top right of that box. And you'll see where it says you have to go to, is it miscellaneous maybe? See over miscellaneous? Yep. Under miscellaneous, it's all the way at the bottom, no, wrong one. It's all the way at the bottom left, where it says log, and then it's a little like a, that's how we're going to get that 2 in there. So it's under functions. You gotta type in y equals first. Yep, and then you go to function, and then you go to miscellaneous, and it's that, yep, that one right there. Log base a, so go to miscellaneous, that log base a thing. And then you can type in 2 as your log base, so right there, the log base a. You guys see where it is? And then you can type in 2 for your little thing, and then put x for your other one. You're gonna see what the graph looks like. And then go answer it. Is it A, B, C, or D? Don't say it out loud. Go answer it.
Oh, I didn't say that.
Did you get it? No.
Yeah.
First one, they did it. And then go to this function.
That's it. It's C. C goes
Anybody else have any issues with it? Did you figure it out? Everybody else getting it? Can you see the answer? What's the answer?
A.
Dead? Okay, cool. Sounds good to me. Leave my pen. Did I leave my pen in somebody's desk? Thanks. That's the 3rd time today I've done it. Alright, so it's answer A. And I don't mind if you want to go right in there. You would be able to do this in a calculator. I'll show you later how to do that. But for now, just use Desmos, okay? Number 9, we're going to sketch this. So you're going to go right into Desmos, and you're going to plug these in. We already have this one, so don't erase that. What was the first point we know on this one? Look at your, matter of fact, make a table. Go to that graph, push the little gear-looking button, and press table. Give me some points. 1, 0 for sure, right? We know that from the previous graph anyway. What's another one? 2, 1. Let's plug that one. Is there a 3? No. Is there a 4?
No.
Oh, I didn't show you how to do that. Yes, there is. I'll show you. Okay, let's do this. PC. This is super, super easy. Watch this. I'm going to type it in right from the start. Y equals the function button right here, miscellaneous log base A of 2. And you got to put x in the parentheses, okay? So I've got my graph here, and again, I go here, and I go table, and here's the thing. I don't know values here, it only tells me this, but look what I can do. I can just click right here, and I'll put 3. And it gives me a really whack thing. I don't want that. But if I go here and I press 4, hey, there you go, 4, 2. There's a nice easy value. So go grab 4, 2. Now, I'm going to give you a guess as to what point is going to be pretty next. 1, 2, 4. What do you think is going to happen next? 6. Let's try it. 6. Yuck. Let's try 8. Oh, that's pretty nice. Look what's happening. Times 2, times 2, times 2. Right? So 8, 3 is another value. You could plot those other ones if you want, but I'm going to come back to my camera here again. 8, 3 is right there. And let's just connect them from there. I like that. Now, if you have 2 different colored writing utensils, a pencil and a pen, anything like that, it'd be nice to do that here, but you don't have to. Because we're going to do the other one together. I'm going to show you, first of all, how to plug it in. So, stay with me here. I've got this graph already. Go down to this next line, 2, and type in y equals. Do that little function thing again, the function log base A right here. You're going to put a 2 in there again. And then inside the parentheses, you're going to put x minus 1, and then end your parentheses, and then take it right here to this button right here, A to the B, so you can put the 2 on there. And it's going to look funky. Now, I'm not worried about stuff on the other side of that 2, because it actually does not exist. We'll get into that later. But let's do a table here. So I'm on this function. I'm going to go to this gear list thingy here again. I'm going to press the table button. And I'm going to get points for that. And you can see a whole bunch of undefined points. And then my first one is at 2, 0. So I'm going to go plot 2, 0 right on my graph, right on my paper. 2, 0. And I'm going to just kind of keep guessing here until I find another value that works. I'm plugging 3. It gives me a nice value, 3, 1. That works out nice. I can grab 3, 1. We try 4. Yuck. 5. Oh, 5 worked out. Right, so once I got a few of these, I'm not as concerned to keep going. I'm going to go back to the picture again, but you can kind of see how that works. I'm going to give you the next couple of points. And so, again, we had 2, 0, we had 3, 1, we had 5, what did it say, 5, 4? Yeah, 5, 4, right here. And then I will tell you the next point that works out is 9, and it's 9, 6. Okay. And again, I feel like I did something wrong here. It was 3, 2, sorry. It was 3, 2, not 3, 1. I don't know why I did that, but that's right. It is 3, 2. Anyways, 3, 2. 3, 2 is the point. That's weird, because it didn't give me that. Weird. Anyways, let's connect the dots. I don't know why Desmos was that wrong, but that's for sure the point. Here we got this. Okay? So I've sketched each graph. And it says here to sketch the graph of each pair of functions on the same coordinate graph. That's what we did. That's kind of the first part, is this. The second part is showing end behavior and intercepts. Well, we showed the x-intercepts. What is my end behavior? Here's how it works. And we kind of hinted at this on a problem up above. For this graph, we're going to say as x approaches negative infinity, y approaches what? So on the blue one, as x goes towards negative infinity, what is y approaching? Well, this line would keep going down here. So y approaches 0. Okay. As x approaches infinity, so as x goes to the right, what's going to keep happening to this blue graph? It's going to keep going up, 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 and it's never ending. So y also approaches infinity. Now, I'm going to zoom this a little bit more. Sorry for that. But all I'm saying is, as the graph goes to the left, it approaches 0. As the graph goes to the right, it approaches, well, infinity. So we can do the same thing on this one. As x approaches negative infinity, y approaches 1, because this graph, this red one, would keep going here, but it wouldn't go past 1. And as x approaches infinity, y approaches infinity. That is for sure as well. Don't let that freak you out. It's just another way of writing the domain and range. Okay? I want you to see it. All right, so. Is the next page homework already? Oh, there's another problem. No, that's it. Next page is homework. Next 3 pages of the homework. I'm going to help you with the hardest problem I have here. Okay? Let's do it together. So there's page 1, page 2. That's all the notes. Okay? You're going to get page 3 of the homework. It's the homework. Let me zoom this out again. Okay, so you've got all of this that you can do easily, especially 1 through 4. You found that probably went pretty fast. Domain and range for number 5. We have an example in our notes that looks just like this. Do the same thing. Okay? You're going to get to these story problems. Don't let this freak you out. Domain is just the x value, right? So look at number 6. It's just saying, what is the domain? So the x values of the function. And what do they represent in the context of the problem? If you read it, it is really, I said, here you go. You can see what I just said. Domain is x. What does the domain mean? That's all it's asking. Okay, if you read it, this is really not as hard as you think it is. Okay, once I break it down to tell you what it is. For number 7, go back and look at what we just finished in the notes. Okay, last problem in notes. Right. You should easily be able to do number 8. Like you could probably do number 8 in 10 seconds. Okay, but and number 9 really doesn't work out too much harder either. Okay. If you just, here, literally write this down. Read graph. Look at what it's asking and just look at the point on the graph. That's all it is. Okay? But this last one is a pain. It is. Okay? You know what? Screw it. Just mark it up. We're not going to do it. All right, so your homework is 3 pages. It's only 1 problem on that last page. I'm telling you guys, in 12 minutes, you can knock out almost all of this. It goes fast. Okay? Use your time wisely, please. 12 more minutes. For sure get through some so you don't get 0 credit tomorrow.